Imagine boarding a train in New York City and stepping out in London just 1 hour later. No airports, no turbulence, just seamless, ultra-fast travel powered by cutting-edge Hyperloop technology. This isn't science fiction. It's a $20 trillion vision to revolutionize transportation and redefine our understanding of global connectivity. This ambitious project envisions connecting New York to London through an underwater Hyperloop tunnel, utilizing advanced magnetic levitation and vacuum-sealed tube technology. This endeavor promises to shrink transatlantic travel times to just 60 minutes. How does this groundbreaking technology work, and what would it take to construct a 3,500-mile underwater tunnel to make it a reality? Let's explore the details. Hyperloop technology operates on two key principles: magnetic levitation, or maglev, and vacuum-sealed tubes. Traditional trains are limited by friction and air resistance, both of which slow them down and increase energy consumption. The Hyperloop eliminates these obstacles. Maglev technology uses powerful magnets to lift the train slightly above the track, eradicating friction. Simultaneously, the train travels through a vacuum-sealed tube, drastically reducing air resistance. These innovations allow Hyperloop pods to reach speeds of 760 miles per hour or more, making them faster, quieter, and more energy efficient than any existing form of ground transportation. The New York to London Hyperloop project stands out not just for its technological ambition, but also for the extraordinary scale of its construction. Building a tunnel beneath the Atlantic Ocean would require unprecedented engineering solutions. To understand the magnitude of this challenge, consider the Channel Tunnel, which connects England and France. At 31 miles long, it is the longest undersea tunnel in the world. The proposed Hyperloop tunnel, by contrast, would span approximately 3,500 miles, more than 100 times longer than the Channel Tunnel. The construction process would begin with advanced tunnel boring machines, capable of cutting through the seabed. These machines would need to handle immense underwater pressure while digging through rock and sediment efficiently. Unlike traditional tunnels, the Hyperloop tunnel would require a pressurized and vacuum-sealed environment to support the system's operation. Engineers would also need to ensure the structure's durability against the pressure of the surrounding ocean and potential geological activity, such as tectonic shifts and underwater currents. One proposed method involves constructing modular tunnel sections on land and then transporting them to the ocean floor for assembly. Each section would be meticulously sealed and connected, creating a continuous, airtight structure capable of housing the Hyperloop system. This modular approach has been used successfully in building undersea pipelines and could provide a scalable solution for this project. The tunnel would also need to incorporate advanced safety features such as emergency exits and maintenance hatches placed at regular intervals. State-of-the-art monitoring systems would continuously assess the tunnel's structural integrity, detecting and addressing potential issues before they become critical. Once the tunnel is complete, the next step would be to install the Hyperloop system. Unlike conventional tracks, the Hyperloop uses a guideway equipped with magnetic systems for levitation and propulsion. Sensors, control systems, and energy infrastructure would also be integrated to ensure optimal performance. The system's power needs would be significant, but engineers are exploring renewable energy sources such as solar panels, wind turbines, and geothermal energy to make the project more sustainable. For example, solar panels could be installed along the tunnel's surface, providing a reliable and renewable source of electricity. The workforce required to build this colossal project would be immense. Constructing a 3,500-mile tunnel beneath the Atlantic Ocean would involve tens of thousands of skilled workers across various fields. Engineers, architects, and geologists would play key roles in designing and planning the tunnel, while environmental scientists would ensure that the project minimizes its impact on marine ecosystems. Construction crews, machine operators, and specialists in underwater assembly would handle the physical building process, working in challenging and often hazardous conditions. Advanced robotics and AI-driven machinery would also play a significant role in supporting the workforce. These technologies would enhance precision, reduce risks, and improve efficiency during construction. For example, robotic systems could be used to assemble modular tunnel sections underwater, while AI algorithms optimize boring machine operations and monitor construction progress in real time. Building this transatlantic Hyperloop tunnel between New York and London would also demand an unprecedented amount of material, primarily concrete and steel. Based on comparable projects like the Channel Tunnel, which utilized 3.3 million cubic yards of concrete for 31 miles, a 3,500-mile Hyperloop tunnel could require an estimated 370 million cubic yards of concrete. Similarly, steel usage would be immense, with millions of tons needed to reinforce the tunnel and construct steel shell concrete segments. Advanced construction techniques, such as the immersed tube method, would require assembling and submerging thousands of massive sections, each containing tens of thousands of tons of material. In addition to traditional materials, the project may incorporate cutting-edge composites like carbon fiber reinforced polymers for pod construction, optimizing strength and weight. However, sourcing and transporting these materials would present significant logistical and environmental challenges. Innovative solutions, including ultra-high-performance concrete and sustainable steel production methods, could help mitigate the impact. To prepare workers for the unique challenges of this project, specialized training programs would likely be developed. These programs would focus on skills such as operating underwater construction equipment, managing high-pressure environments, and working with vacuum-sealed systems. Collaboration across multiple industries and international borders would be essential, creating a workforce as diverse and innovative as the project itself. While the Hyperloop tunnel's construction would be a monumental feat, the passenger experience aboard a Hyperloop pod would be just as transformative. Imagine stepping into a sleek, futuristic capsule with spacious seating, virtual windows displaying calming visuals, and advanced climate control systems. The ride would be nearly silent, free from the turbulence and noise associated with air travel. Passengers could relax, work, or even sleep as they travel the Atlantic at nearly the speed of sound. Despite its promise, the Hyperloop project faces significant challenges. The $20 trillion price tag is one of the most daunting hurdles. Funding this endeavor would require unprecedented levels of international collaboration. Governments, private investors, and multinational corporations would need to pool resources, share expertise, and align their goals to bring the project to fruition. Legal and regulatory issues, particularly those involving international waters, would add another layer of complexity. Public perception is another obstacle. While the idea of traveling from New York to London in 1 hour is exciting, the concept of doing so in a vacuum-sealed tunnel thousands of feet below the ocean may feel intimidating to many potential passengers. Addressing these concerns would require rigorous safety testing, transparent communication, and clear demonstrations of the technology's reliability. Emergency evacuation systems, regular maintenance schedules, and advanced monitoring tools would be critical to ensuring passenger confidence. The environmental impact is another key consideration. While the Hyperloop system itself is designed to be energy efficient and sustainable, constructing a tunnel of this magnitude could disrupt marine ecosystems. Engineers and environmental scientists would need to work together to mitigate these effects, such as by rerouting the tunnel to avoid sensitive habitats or employing quieter construction methods to minimize noise pollution. If successful, the Hyperloop train from New York to London could revolutionize global travel and commerce. Business trips that currently require long-haul flights could be completed in a fraction of the time, opening up new opportunities for international collaboration and economic growth. The system could also facilitate faster delivery of goods, streamlining supply chains and boosting trade between continents. In the long term, this project could pave the way for a global Hyperloop network. Imagine connecting major cities across continents, Tokyo to Los Angeles, Sydney to Singapore, in just hours. Such a network would not only make the world feel smaller, but also reduce the environmental impact of air travel, which is a significant contributor to global carbon emissions. Critics, however, argue that many aspects of the Hyperloop remain untested. While the prototype systems have demonstrated the feasibility of the technology, scaling it up to handle thousands of passengers across a transatlantic route presents unprecedented challenges. There's also the question of economic viability. Can such a massive investment ever be recouped, or will it remain a futuristic dream? Throughout history, bold infrastructure projects have often faced skepticism before becoming transformative. The Transcontinental Railroad, the Panama Canal, and even the Channel Tunnel were all considered impossible at one point. Yet they reshaped economies, connected regions, and changed the course of history. The Hyperloop has the potential to do the same, ushering in a new era of high-speed sustainable transportation. Imagine a future where cities and continents feel like neighbors, where global travel is fast, efficient, and environmentally friendly. The Hyperloop isn't just about speed, it's about redefining what we can achieve as a global society, whether it takes decades or even centuries to realize. The dreams of a one-hour journey from New York to London reminds us that human innovation has no limits.